projects. In this video, we are going to explain about a project titled A Recurrent CNN for Automatic Detection and Classification of Coronary, Artery, Plaque and Stenosis in Coronary CT Angiography. Now coming to the introduction part. The introduction of the recurrent CNN for automatic detection and classification of coronary artery, plaque and stenosis in coronary CT angiography represents a significant advancement in the field of cardiovascular imaging and CAD diagnosis. By combining the power of deep learning with recurrent neural networks, this innovative approach offers a robust and automated solution for identifying and classifying coronary artery, plaque and stenosis, ultimately contributing to more efficient, accurate and personalized patient care. TCTA is a non-invasive imaging technique that provides detailed images of the coronary arteries, making it an essential tool in diagnosing CAD. However, manually analyzing these images can be time-consuming and prone to human error. The recurrent CNN offers an efficient and reliable solution to address these challenges. So our main objective for this project is the recurrent CNN for automatic detection and classification of coronary artery, plaque and stenosis in coronary CT angiography aims to advance CAD diagnosis and management by providing an automated, accurate and personalized solution. By harnessing the potential of deep learning and recurrent neural networks, this innovative method has the potential to transform cardiovascular imaging and patient care, ultimately improving patient outcomes and contributing to better cardiovascular health. Accuracy is another crucial objective of the method. By leveraging the strengths of convolutional neural networks for image feature extraction and recurrent neural networks for temporal analysis, the model aims to achieve high accuracy in identifying coronary artery plaque and classifying its severity in terms of stenosis. This accuracy is vital in ensuring early detection and timely intervention to prevent further complications. The recurrent CNN also aims to provide reliable diagnosis support to healthcare professionals. By learning from a diverse dataset of annotated CCTA images, the model gains a comprehensive understanding of coronary artery disease characteristics, enhancing the quality of diagnosis and reducing the risk of misinterpretation. Now coming to the requirements, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, versus operating system, that is Windows, is required. Processor i5 and above. Minimum 4 GB of RAM is required. Hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. Now coming to the methodology part, first we have upload CCTA scan plaque dataset. The first step in this process is to upload the CCTA scan plaque dataset. This dataset contains a collection of coronary CT angiography, that is CCTA images that have been annotated with information about the presence of coronary artery plaque. The dataset is essential for training and evaluating the performance of the RCNN model for plaque classification. Second, dataset preprocessing. After uploading the CCTA scan plaque dataset, the next stage involves preprocessing the images. Preprocessing techniques are applied to ensure that the images are in a standardized format and ready for training. Common preprocessing steps may include resizing the images to a consistent resolution, normalizing pixel values, and removing any artifacts or noise that could affect the model's performance. Third, generate and load RCNN model. Once the dataset is preprocessed, the next step is to generate and load the RCNN, that is recurrent convolutional neural network model. The RCNN model is a type of deep learning architecture that combines the power of both convolutional neural networks that is CNNs for image feature extraction, and recurrent neural networks, that is RNNs for temporal analysis. This unique combination allows the model to analyze sequences of images over time, making it particularly well suited for tasks like plaque classification in CCTA scan. Fourth, plaque classification. With the RCNN model generated and loaded, the next objective is to use it for plaque classification. The model takes the pre-processed CCTA scan images as input and analyzes them to determine whether coronary artery plaque is present or not. Plaque classification is a critical step in identifying patients at risk of coronary artery disease and facilitating appropriate medical interventions. Fifth, RCNN training graph. To evaluate the performance of the RCNN model during training, various metrics such as accuracy, loss, and validation scores are computed. These metrics are plotted on a training graph, which provides a visual representation of the model's learning progress over time. As the RCNN model is trained on the CCTA scan plaque dataset, the training graph helps to monitor how the model's accuracy improves and its loss decreases with each iteration, demonstrating the effectiveness of the training process. Now coming to the execution part. To execute the project, first we need to open the code folder. Here we have 4 folders, that is dataset, which is containing 2 folders named as plaque and no plaque. So here no plaque containing some images and plaque also containing some images. Here we have a folder named as model, which contains .h5 files and .n5 files over here. So here .h5 files which contain the deep learning algorithms information. These .h5 files can be loaded into the project code during runtime to utilize the trained model for various tasks, such as making predictions of new data or performing specific operations. And here .n5 files also contain some Python datasets in it. Here stent folder contains 2 images in it, that is stent 1 and stent 2. Test images containing some images for testing it. Here main and test train are the 2 Python files which are containing Python scripts in it. Here this is the main Python file which is containing the Python script in it. And this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. This is the graphical user interface. With this we are interacting with the program. Now click on upload CCTA scan plaque dataset button to upload dataset and get the output. Here select dataset and click on select folder button to load dataset. Here on this screen dataset loaded. Now click on dataset preprocessing button to process dataset for getting the output. Here on this screen you can see that class labels in dataset and total images available in dataset with train and test images size, and on this screen displaying sample process image to check all images are loaded and processed properly. Now close this image and click on generate and load RCNN model button to generate RCNN model for getting the output. Here with RCNN we got accuracy as 84% and in confusion matrix graph X represents predicted classes and Y represents true class. And in this graph we can see only 2 images of no plaque is incorrectly predicted as plaque. Now closing this graph, click on plaque classification button to upload test image for getting the output. Now selecting the first image, click on open for getting the output. In this image we can see blue color text, we can see classification result as plaque detected over here and stenosis also detected. Now we will test by uploading other images. So here we can see that plaque is also detected over here. Similarly, we can test with other images also. Now click on RCNN training graph button to get the graph. Here you can see x-axis represents images, whereas y-axis represents accuracy and loss values. And here red line represents loss, whereas green line represents accuracy. And in this graph we can see with each increasing approach accuracy got increased and loss got decreased. So after closing this project, now coming to the conclusion part. In conclusion, the recurrent CNN for automatic detection and classification of coronary artery plaque and stenosis in coronary CT angiography holds great promise as a transformative tool in CAD diagnosis and management. By harnessing the potential of deep learning and recurrent neural networks, this innovative method paves the way for more efficient, accurate, and personalized care for patients with coronary artery disease, ultimately making a significant impact on cardiovascular health and patient well-being. The accuracy and precision of the recurrent CNN in detecting and classifying coronary artery disease conditions are noteworthy achievements. By effectively extracting facial and temporal features from CCTA images, the model can identify intricate patterns associated with coronary artery plaque and accurately classify the severity of stenosis. This level of precision is crucial in enabling timely interventions and tailored treatment plans, ultimately enhancing patient management and reducing the risk of complications.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.